In this video, we'll generate the associated Legendre polynomials using Google Sheets and Excel functions, COMBINA, SERIESSUM, in the Taylor series expansion. This is the Taylor series expansion of the associated Legendre polynomial, and the coefficient and the values of k from 0 to n minus n, where the value of n is data validation, list of items 0 to 10, and our value of m is data validation, list of items 0, 2, 4, 6. This means that we are limited only to the even numbers because of this expression in the Taylor series expansion, which is zero point 0.5 times 10 to the m times the quantity 1 minus x squared raised to the power m over 2. So the value of m is even. Now we calculate the formula for the value of k, which is sequence n minus m plus 1, 1 column, 0, comma 1. So that if value of m is 2 and the value of n is 5, your values for k 0, 1, 2, 3, because that's 5 minus 2, which is equal to 3, and our k values would be from 0, 1, 2, and 3. Now we enter the Taylor series. So array formula, series sum of the x values, which is quantity x minus 1, over 2, raised to the power k starting from 0, incremented by 1, and the coefficient will be this range. Now we continue with the rest of the Taylor series expansion. We have 0.5 to the power negative 0.5 to the power m. So that's minus 0.5 raised to the power m times, next will be, that's x minus 1 minus x, it's 1 minus x squared, that's 1 minus x squared raised to the power m over 2, m over 2 times series sum. Now we have completed the Taylor series expansion formula. That's 0.5 minus 0.5 to the power m, 1 minus x squared raised to the power m over 2, and the series sum. Next, we continue with the coefficient, which is equal to our formula, that is factorial n plus m plus k. So that if k is empty, this should be 0. So we'll correct this. So if k is empty, k is empty. So if k is empty, 0. Otherwise, calculate. Now it's corrected. Continue with the second term, combina. So times combina. That's combina. That's n minus k minus m plus 1. So n minus m minus k plus 1, comma m plus k. So m plus k. So here you have the numerator part. So we have completed the numerator part. Now we continue with the denominator, which has two parts. Factorial n times factorial k. So we start with 0 for n and n. At n equals 0 and Rn is 0, our polynomial is y equals 1. At n equals 1, the polynomial is 1x. 1x. At n equals 2, that's minus 0.5 plus 1.5x squared. N equals 3, that's minus 1.5x plus 2.5x cubed. Now we go to m equals 2. So start from n equals 1. No, there's no data. We'll start at n equals 2, same number. So our polynomial will be 3 minus 3x squared. That's 3 minus 3x squared. N equals 3. Our polynomial will be 15x minus 15x cubed. N equals 4. It will be minus 7.5 plus 60x squared minus 52x to the 4th. So minus 7.5 plus 60x squared minus 52x to the 4th. So at n equals 3, at n equals 4, polynomial will be 105 minus 210 x squared plus 105 x to the 4th. N equals 5. It will be 945x minus 1890x cubed plus 945x to the 5th. This completes the use of COMBINA, SERIESSUM in Taylor series expansion, and LINEST polynomial regression to generate the Legendre polynomials, associated Legendre